Hi, Math 20. Let's check out section 3.3, problem number 6 from the book. And it tells us that -2 is a 0, or actually we want to determine if -2 is a 0. And then if it is, we're going to find all the other zeros of f of x. So I'm going to use synthetic division. So we'll put -2 on the outside. And our f of x is x cubed, or 1x cubed, so that's a 1, minus 4x squared, minus 2x plus 20, and then we're not missing any terms, so we don't need to worry about any zeros. So let's do the long division and see if -2 is a 0. So we bring the 1 down. -2 times 1 is -2. We get -6. -2 times 6 is positive 12. And so then we add -2 plus 12 and we get 10. We multiply again and we get -20, and we add and get 0. Meaning because there's no remainder, x equals -2 is a 0. So if we want to find the other two zeros, we could continue with division, or we could just factor what's left over. So since we started with x cubed, we go down a degree to x squared. So we get x squared minus 6x plus 10 equals 0. So our options, since it's a quadratic, we can factor if it's factorable, or use the quadratic formula. I like to try to factor because it is faster, but I can't think of anything that's a product of 10 and a sum of -6. Yeah, 5 and 2, 10 and 1, there's no way those are going to add up to -6. So I guess we'll have to jump into the quadratic formula to find the other two zeros. So we have a equals 1, b equals -6, and c equals 10. And then we really want to memorize the quadratic formula because it is used enough in the STEM pathway. So we get -b plus or minus b squared minus 4ac all over 2a. If you don't know this, I would just YouTube the quadratic formula song. Or you could look up my YouTube page. I'll link it from my YouTube page as well. It's a very annoying song, but you will memorize it. So let's see, what do we get? We get -6 plus or minus -6 squared minus 4 times 1 times 10 for 4ac all over 2 times 1 for 2a. So we get 6 plus or minus 36 minus 40 all over 2. So 6 plus or minus -4. So square root of -4 all over 2. And then the square root of -4 would be an I for the negative and 2 for the 4, so 2i. 6 plus or minus 2i all over 2. And then if you want to cancel, you have to cancel everything. So I find it easier to just factor the top. So you can't do 6 and 2, that's not allowed. That was a cat dog fight. Hey, stop. So we're going to go ahead and factor the 2 out since 6 and 2 have 2 in common. So we get 3 plus or minus I, factored out the 2, all over 2, and the 2 cancels out. So my zeros are 3 plus I, 3 minus I, and then the original one was -2. So hopefully that helps. Oh yeah, and then we need to add the complete factorization. So the complete factorization will be x minus each zero. So the imaginary ones are a little difficult. Let's start with the -2 because it's a little easier. So it'll be x minus -2, which we know is x plus 2. And then the other two are a little tricky. It'll be x minus 3 plus I, but it's important that it's minus the whole thing. So you need parentheses on the 3 plus I. And then x minus 3 minus I, again, you're minusing the whole thing, so we need parentheses. And then we'll just go ahead and distribute that negative sign, and we'll be done. So we have x plus 2 for the first one, because x minus -2. We get x minus 3 minus I, and we get x minus 3 plus I. And that is considered my complete factorization. Factoring is funny when we have i's because we don't typically do it, but for complete factorization, that's what it would look like.